This is section 9.4, part A, polar forms of conic sections. So if you need to write polar equations in rectangular forms, first you're going to need to analyze the polar equation. So when you're doing that, you need to determine the E and the D values for the equation and whether the directrix will be horizontal or vertical. Next, you will need to determine the values for h, k, and p if it's a parabola, or the values of h, k, a, and b if it is a hyperbola or an ellipse. You will need to substitute the values into the standard form of the equation of parabola, ellipse, or hyperbola, and then you're going to need to write an equation of c equals a times e. So as a refresher, the standard forms of a parabola, if it opens vertically, is x minus h squared is equal to 4 times p times y minus k. If it opens horizontally, it's going to be y minus k squared is equal to 4p times x minus h. You're going to have our parabola open vertically if the directrix is y equals the d value, and the directrix is equal to x equals the d value if it is opening horizontally. Now for an ellipse, remember our two forms are going to be y minus h squared over a squared plus, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. If it is stretched horizontally, if it's vertically, it's going to be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And for a hyperbola, if it opens horizontally, the x is going to come first in the equation. If it opens vertically, the y will come first in the equation. So if we take a look at this equation, remember that the equation of a conic section is in the form of E times D over 1 minus E sine of theta. So based on this, since there's no value right in front of sine, we know that E will be equal to 1. Since the eccentricity is exactly 1, we do know that this is going to be a parabola. Now we also know that our numerator is equal to E times D. So if E times D is equal to 4, and we know that E is equal to 1, we know our D value is 4. Because this is sine, we know our directrix is going to be y equals, and because this is a negative or a minus, we know it's going to be y equals negative d, or y is going to equal negative 4. So since we know our directrix is y equals negative 4, we can come back and we can look at our parabolas. When our directrix is y equals, it means our graph is going to open vertically, and it's going to be in the form of x minus h squared is equal to 4p times y minus k. Now we are going to have to get some more information. So it's going to do us some good to actually graph this on our graphing calculator and see what this graph looks like. To do this, the first thing you're going to have to do is to change your graph to polar form. So on your graphing calculator, you're going to hit mode, you're going to make sure we're in degrees, and you're going to change it to polar. Next, you're going to go to your window. In polar, we're going to have different settings than you do if you were in function. And so our theta minimum should be 0. Our theta maximum, because we're in degrees, we're going to do 360. And we're going to let our theta step equal 5. We're going to let our x minimum be negative 10, our x maximum be positive 10, our x scale to be 1. Let's let our y min be negative 10, our y max be 10, and our y scale equal to 1. And if you look at the graph on your graphing calculator, we should see that it looks something like this. If you hit the trace button and you move from left to right, it may not move in the direction you expect it to because it is going around in a circle, so you may have to go in a direction you don't expect to go. But we can see that the theta value here is 0 degrees with an x value of 4 and a y value in rectangular of 0. This point is at theta equals 270 degrees. The x value that corresponds is 0, and the y value that corresponds is -2. And over here, we are at theta equals 180 degrees. The x value that corresponds is -4, and the y value that corresponds is 0. Now, based on this, we do know that this is our vertex, or our H and our K. So we do know that our vertex will be at 0 and -2. So we do know the H and the K for our equation, but we have to find that P value. Now, we know that because we're using the formula y minus h squared, if we come back up here and look, our focus is h and k plus p. So, if we come and look, the p value is telling us how far it is from our other value. We know that we have a point, the middle right here, is telling us how far away it is to get to the other point. This is our focus. It's in line with our 2 points, and our focus is at 0, 0. We know that the focus has an equation of h and k plus p. So I know h is equal to 0 because our focus is at 0, 0. And we know that k plus p is equal to 0. Now we already know from over here that our k value is -2. So if we take that to the side, we're going to see that p is equal to 2. So now we have our h, our k, and our p. So we can go ahead and write our equation. So this is going to be x minus 0 squared is equal to 4 times p times y minus our k value. Or if we simplify this, we can just write it as x squared is equal to 8 times y plus 2. And we do know that this will be a parabola. We need to write the polar equation for this in rectangular form. So again, the first thing we're going to do is we're going to identify what type of conic. We're going to identify the E, the D value, and then from there we'll figure out everything else we need to find. So because this is cosine and because this is a negative, cosine tells us that our directrix will be x equals, because this is a negative value, it's going to be a negative here. But we're going to have to find that value first. Now remember, the value right in front of your sine or your cosine is your eccentricity. So our eccentricity is 0.6, which does tell us, because this is between 0 and 1, that it is going to be an ellipse. Now we know this numerator is equal to E times D, and we already know that that eccentricity is 0.6. So if we solve for the value of D, we're going to divide both sides by that 0.6. We will get that the value for D is equal to 5 1/3. So we do know that the directrix will be x equals negative 5 1/3. So since the directrix is x equals negative 5 1/3, the major axis, because the directrix is x, the major axis will be on the x-axis. So the general form of the equation, because this is an x, we know the general form of our equation will be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now, this is where we're going to have to graph it on your calculator. It will be in polar form. And your graph should look something like this, where we have this point is at -2, 0, and this point over here is at 8, 0. So we can find the center first. Our center is going to be located at the midpoint of those, so -2 plus 8 over 2 and 0 plus 0 over 2, or our center is going to be located at 3 and 0, which are your H and your K. Now we know that the distance between the vertices is equal to 2a. So if we do the larger minus the smaller, the distance from 8 to -2 is 10, or a is equal to 5. And we know that the eccentricity is equal to c over a. Our eccentricity is 0.6, our a value is 5, so that means our c value would equal 3. Because this is an ellipse, if you remember back from chapter 7, we know that a squared minus b squared, let's get that, an ellipse is minus because it is the opposite, is equal to c squared. So our a value is 5, our c value is 3, 25 minus b squared is equal to 9. If we take the 25 to the other side, we're going to get a -16. Divide both sides by a -1. B squared is equal to 16, or our b value is equal to 4. So we have a, we have b, we have our h and our k. We can now write our equation. So this is going to be x minus 3 squared over a squared, which will be 25, plus y minus 0 squared over 16 is equal to 1. If you wanted to write that as just y squared over 16, that would work as well, because you can just combine the y and the 0, since the 0 does not have an actual value.